In this case, calculate current in the galvanometer for the figure shown below using the Thevenin theorem. Where is the galvanometer? This is galvanometer. And resistance of this galvanometer is given as it is 10. This is right. Our first step is to remove the load resistance and redraw the same circuit. I will write this here. How complicated figure, it doesn't matter. The procedure will be the same in case of this application. I will write the same. Removing load resistance and redrawing the same figure. If we will remove the load resistance and if we will redraw the same figure, how will be the figure? The figure will be something like this. This we are removing this. This will be the figure. This is one resistance, this is the second, this is the third, this will be the fourth resistance, this will be the fifth, and this is the next. This is right. This point I will name it as A, this point I will name it as B. This is right. And I will redraw the remaining figure. It will be something like this. This is the figure. It is the 12 volt plus minus. Here it is 8 ohm. This is 6 ohm. This is 10 ohm. This is 5 ohm. This is right. This is 8 ohm. Here it will be 7 ohm. Right. So here in this case, this will be the figure. So in this case, we are interested in the calculation of the potential between the points A and B, which is the Thevenin voltage. Because we have removed this load resistance, which is 10 galvanometer. That's something like this. Now we are interested in the calculation of the voltage between the points A and B. We can travel from the B by using this path, maybe this path, or maybe this path. We'll use this path. Or you can use this path, one and the same thing. Because we are interested in the calculation of current in one and second branch, first and second branch. Is it right? Now, which method you will use? Which method we will use here? There are a number of ways. Here, I will prefer the direct inspection method, or maybe the mesh analysis, because the nodal will become very complicated. Is it right? In this particular case, this will be the one node, this is the second node, this is the third node, we have the three nodes, and it becomes more complicated. We will prefer the direct inspection. I will prefer the direct inspection or mesh analysis. This is our first loop, which current is I1. Loop kaise hoga? This is the first loop. Something like this. This is the second loop, which current is I2. And this is my third loop, and its current will be I3. Ye third loop aise hoga. It will be something like this. This is right. Third loop. You can directly mark the polarities plus minus, apply the KVL to the loop 1, loop 2, and loop 3, or you can use the direct inspection method. I will prefer here direct inspection method. Now look at how is the direct inspection method. I have discussed that. R11, R12, R13, R21, R22, R23, R31, R32, R33. Is it right? This is the matrix. How will be this matrix? I will draw the matrix first, and then I will come back to you. I1, I2, and I3. These are the three unknowns, which is equal to the constants. Is it right? Which is equal to the constants. So here in this case, first I will find out the R11, resistance of the first loop only. How much is the resistance of the first loop? Can anyone tell the answer? Here, this is my first loop. ये मेरा first loop. If this is 8 plus 8, 16, plus this 6. How much? And then 5, and then 7. This 8 plus 8 plus 6 plus 5 plus 7 is the R11, that is resistance of the first loop. How much is the value? Yes. Anyone? Look at this. This is 8 plus 8 plus. This is 8 plus 8 plus. This is 6 plus. This is 5 and finally plus 7. How much is the value? 34. Is it right? This R11 is the 34. And in this direct inspection method, only the diagonal elements are positive, remaining all elements are negative. 34 is the loop 1 current. I will check once again. 8 plus 8 plus 6 plus 5 plus 7. Absolutely fine. Then R22. How much is the resistance of the second loop? Now look at this. This is the second loop. Is it right? How much is the value? 10 plus 5 is the 15 and the 6 will be 21. This 21 is the R22. How much is the R33? Resistance of the third loop. Look at which is the third loop. This is my third loop. This is my third loop. Here is the third loop. How much is the value? This 10 and this 7 will be the 17 and 17 is this R2. Sorry, R33. But be careful about this method. This method has many limitations. एक भी करंट सोर्स अगर यहाँ पे होगा तो we are not able to use that method directly. Is it right? तो इस मेथड को डायरेक्ट इंस्पेक्शन मेथड को तभी ट्राई करना है whenever all the given sources are the voltage sources. Now I will come back. So I will find out these two values, R12 and R21, the resistance which is common for the first and second loop. Look at this. Is my first loop. ये हमारा first loop है. This is my first loop. Is it right? And this is my second loop, which is the common branches 6 and 5. These are the two common branches available in the loop 1 as well as available in the loop 2. 6 and 5, which is 11. This value is minus 11. This is again minus 11. Now find out the resistance which is common for the first and third loop. Now look at carefully. How is my first loop? This is my first loop. This is my first loop. ये मेरा first loop है. This is my first loop. And how is my third loop? This is my third loop. In this case, only this 7 resistance of the first loop is common to the third loop. That's right. This is minus 7. This is minus. What is the next? Next is R23 and R32, resistance which is common for the second and third or third and second loop. This is my second loop and this is my third loop. Which resistance is common? This only, that is minus 10 and this is again minus 10. Is it right? How much is the constant for first loop? First loop में कोई भी source नहीं है. You will travel with the direction of current. There is no source. That's why there is 0 constant for first loop. How much is the constant for second loop? If we are traveling with the direction of the current, there is no voltage source. This is constant is again 0. How much is the constant for third loop? Now look at it. If we are traveling with the direction of the current, we are traveling from negative to positive plus, and its value is the 12. Is it right? This is the way to find out direct inspection method. You can use any method, believe me. मैंने inspection use किया इसलिए आपको भी inspection use करना है. ऐसा जरूरी नहीं है If you are not compatible with this, then apply the KVL to the first loop, KVL to the second loop, KVL to the third loop, you will get the same equation. This is right. Now from this equation, calculate all the currents, I1, I2 and I3. Then we will discuss about the calculation of the VTH. अगर इस मेथड में किसको डिफिकल्टी है, just raise your hand. I will clarify your doubt. I will come back to you. Akash, Avinash, Chaya, Madhuri, Rishikesh, Ruchira, Saurabh. Any doubt about this method?
No, sir.
No. Yes. Now find out the I1, I2, I3 now, and then we will calculate the VTH. Yes. Use the matrix. I've used the calculator to solve these equations. I1, I2, I3. Find out these values. Yes. Saurabh.
I1 0.75.
I1 is
0.75.
It is 0.75 amperes. I2
1.21 amperes.
1.21 amperes. I3
1.73.
1.73 amperes. Is it right? If we know these values, then I'm interested in the calculation of the VTH. Look at use any path. I'm using this path. This path we use करो. You can use this path also. There is no difficulty. क्योंकि हमारे पास सभी calculations हैं. Is it right? You can use this path or you can use this path. Now look at, if I'm using this path, I have three elements, 1, 2, 3. If I'm using this path, only the two elements. That's why I will prefer this. ये path मैं use करूँगा. If we are traveling from the B towards A, now mark the polarities in the proper way. Mark the polarities in the proper way and then do that calculation. Now look at how will be the calculations. In this case, now look at how is the I1. This I1 is a flowing downward. This is plus and this is minus. As far as the I1 is concerned, this is downward. This is plus and minus because I'm using this path. That's why I'm interested in these four instances only. लेकिन इसमें I2 भी है. How is the direction of I2? Forward. This is plus and this is minus. Means opposite to that of the I1. Now look at carefully how will be the calculation. I'm traveling from the B towards A. I'm using the sign conventions of I1. If we are traveling in this direction, negative to positive, which is a plus. Its resistance is the 6. If I'm using sign conventions of the I1, means I am assuming I1 is greater than I2 if both are opposite to each other. Is it right? Because I am assuming this I1 as the main current phase resultant current will be I1 minus I2. Is it right? Current in this branch. I am using the sign convention of this I1. If I am using the sign conventions of the I2, then positive to negative, which is minus 6 into I2 minus I1 will be the value. But I am using the I1, that's why it is minus to plus, that is a plus. Its resistance is 6 and its current is the I1 minus I2 because I1 is the main current, I2 is the subcurrent. Then negative to positive, which is a plus. Its resistance is 8 and its current is, what is the current? I1. That's it. Which is equal to, this is plus 6 into I1 minus I2. Is 0.75 minus 1.21 plus 8 into I1, which is 0.7. Complete this calculation and find out the VTH. That is the Thevenin's equivalent voltage. Find out the value of VTH. Yes. Yes, Avinash. Unmute yourself. I will come back to you. Yes.
3.24.
3.24. This is 3.24 volt is the value of VTH. If we know the value of the VTH, then we can find out the RTH. We can find out the RTH. Now look at here. How is the calculation of RTH? How is the calculation of RTH? Yeah. Now, how is the calculation of RTH? I will write some points for this. For the calculation of RTH, load resistance is removed and all sources are replaced by respective internal resistances. This is right. Respective internal resistances. How will be the figure? I will draw the figure as it is. This is my load. I will remove this load. Already we have done in the step number 1. This figure will be something like this. This is my figure for the calculation of RTH. This is A point. This is right. 8 ohm. This is 6 ohm. This is 10 ohm. This is 5 ohm. It is A point. This will be the B point. It is the 8 ohm and this is the 7 ohm. Is it right? And this is the battery which is replaced by its internal resistance. It will be something like this. This is right. This is the figure because this is the voltage source replaced by zero resistance, means this is the figure for the calculation of RTH. This is the figure for the calculation of RTH. Now, I expect the answers from your side. How will be the series and parallel combinations? Yes, anyone? If anyone has a doubt, please raise your hand. Yes. Now, as I discussed in the previous example, first try to take the terminals outside. ये जो terminals हैं ना जहाँ पे हमें resistance find out करना है. These are the two terminals for which between which we want to find out the resistors A and B. First, try to take these terminals outside. That will make some sense, and we are in a better position to find out its value. Always, this figure is same as. Now look at what I'm doing. I'm assuming that this figure is made up of elastic. What I will do, I will pick up this point B. I will pick up this point B and I will put this point B outside here. Is this resistance will be somewhere here, this resistance will be somewhere here, and this connection which is from outside, I will put this connection inside. Is it right? First, I will draw the figure. If anyone has any doubt, please raise a hand after completion of this figure. I will draw this figure. This is A point. Here is one resistance. This is another resistance. Look right. This is 8 ohm resistance. This is also 8 ohm resistance. Is it right? I will check it out. Both resistances 8 here. This is 8. This is 8. Fine. Here is this 7 ohm resistance. I will keep as it is. This 10 ohm resistance I will keep as it is. This is 10 ohm. This is 7. Is it right? What I will do, I will pick up this point and I will take it as outside. In that case, this is 10. In that case, here will be the point. This is one part. This is another branch. This will be the 6 ohm. This will be the 5 ohm. Is it right? And then between these 2 points, ये जो outer shape है, ये 2 points के बीच में ये short circuit wire मैं draw करता हूँ. 1, 2, 3, 4. Here is this wire. Here is this wire. And this point is our B point. Any difficulty in understanding this particular figure? What I have done? Just I have taken this outside and I have shifted this wire internally. इसको difficulty है? Saurabh, any difficulty?
No, sir.
No. Ruchira. Ruchira.
No, sir, no difficulty.
No difficulty. Rishikesh.
No, sir, no difficulty.
No difficulty. Madhuri. Madhuri, any difficulty in understanding this figure? Chaya.
No, sir.
No difficulty. Avinash.
सर वो शॉर्ट सर्किट क्यों किया वो नहीं समझ में आया.
Look at short circuit मतलब ये देखो ये दिख रहा है अभी 1 2 3 4 ठीक है. यहाँ पे भी 8 ओम 7 ओम 10 ओम ये ऐसे ही है. लेकिन ये जो वायर बाहर से कनेक्टेड था जस्ट इसको मैंने अंदर से कनेक्ट किया है. लंबा वायर ऐसे कनेक्ट करो या ऐसे कनेक्ट करो, मीनिंग इज द सेम. इस वायर को ऐसे बाहर से कनेक्ट करो या अंदर से कनेक्ट करो, दैट इज द सेम. अंडरस्टूड?
हाँ. यस सर, यस सर.
हाँ. और ये वायर मैंने क्या किया, अंदर से डाला है और इस पॉइंट को मैंने बाहर दिया. इट इज समथिंग लाइक दिस. नाउ देयर आर मल्टीपल वेज, देयर आर नंबर.
हाँ सर, समझ.
There are number of ways. How is the next step that I will discuss? Now look at it. ये दोनों points के बीच में wire है. I can bring these 2 points close to each other. ये दोनों points को मैं एक ही जगह पे ला सकता हूँ. If I am doing that, how will be the next figure? This is A point. I will draw this figure as a ray. जस्ट रीएडजस्ट कर रहा हूं मैं फिगर को. ये दोनों पॉइंट्स को मैंने एक जगह पे लिया है. दिस इज 8 ओम, दिस इज 8 ओम, राइट. उसके बाद ये पॉइंट और ये पॉइंट दोनों एक जगह पाएंगे. मीन्स इट विल बी समथिंग लाइक दिस. हियर इज वन ब्रांच, इज इट राइट, एंड हियर इज अनदर ब्रांच. आई विल गिव द नेम्स फर्स्ट. 7 एंड दिस इज 10. ये दोनों को भी एक जगह पे मैंने लिया है. This is 7 ohm and this is how much? 10. या तो अगर समझ में नहीं आ रहा कुछ, then you can convert this directly delta into the star. That will simplify your case. But what I am trying to do without the star and delta conversion, इसको कैसे solve किया जा सकता है? अगर आपको लग रहा है कि whatever I am discussing it is too difficult, in that case you can convert this directly delta into the star. Again it will simplify your case. या तो यहाँ पे ही अगर इस डेल्टा को आप स्टार में कन्वर्ट करते वहां पे ही सोल्यूशन मिल जाता. इज इट राइट? बट हियर दिस पॉइंट 10 एंड इसके बीच में ये दो रेजिस्टेंसेस है. इस वन रेजिस्टेंस इज समथिंग लाइक दिस एंड दिस इज अनदर रेजिस्टेंस व्हिच इज समथिंग लाइक दिस. इज इट राइट? व्हाट आर दोस रेजिस्टेंसेस? इट इज 6 ohm and this is 5 ohm and this point is the B point. Are you getting me? I will repeat once again. ये दोनों पॉइंट्स को मैंने एक जगह पे शिफ्ट किया. These are the two parallel. ये दोनों पैरेलल हो जाएंगे, ये दोनों पैरेलल हो जाएंगे. It is something like this. उसके बाद ये पॉइंट इधर शिफ्ट हो गया, यहाँ पे सेंटर पे ये पॉइंट ऑलरेडी यहाँ पे। नाउ दिस टू ब्रांचेस आर समथिंग लाइक दिस एंड दिस इज द पॉइंट बी। Is it right? Now find out the series and parallel combination and draw the next figure. इस फिगर को इस फिगर में कन्वर्ट करने के लिए हमने कोई फार्मूला यूज नहीं किया. We are not used any formula. Just we have used the readjustments in the figure. It is something like this. It's here. It is the point A. These two resistances I will replace by single resistance. Something like this. These two resistances I will replace by single resistance again. Something like this. Is it right? This is my B point. एक रेजिस्टेंस यहां से है और दूसरा रेजिस्टेंस मेरा यहां से है. Is it right? This is 6 ohm. This is 5 ohm. This is the parallel combination of the two, and this is the parallel combination of the two. Its parallel combination will be the 4 ohm. Is it right? Now find out the parallel combination of these two, which is I have drawn here. 7 is parallel with the 10. That is 70 divided by 17. This is 70 divided by 17. That is 17. How much is the value? I guess 4.11. Is it right? So this value is 4.11 ohm is the value. There are number of ways. मैं यही डिस्कस कर रहा हूँ, इसका मतलब यही नहीं है. You can convert this delta. It is 1, 2, 3. Zero resistance का भी delta हो सकता है. This is one delta. This is another delta. You can convert this delta into the star, this delta into the star. That will give the same answer again. But that method will be a little more lengthy. Is it right? Now, look at how is the case. ये दोनों series में है. Series combination इसके parallel में है. Now I will try to draw the vertical figure. This is one, which is 4 ohm. Here is the point A. यहां से मैं ऐसे ड्रॉ करूंगा. Just I am modifying the shape of the figure, nothing else. This is B. Just इसको मैंने vertically लिया है यहाँ. I have taken this point vertically. Is it right? This 6 ohm तो यहाँ पे रहेगा. This will be the 6. This is 4 as it is. And the series combination of the two I am writing here, which is 5 plus 4. That is 9.11. This is 9.11 ohm. Right? The next of this will be one resistance here, second resistance here. This is A point, this is B point. This resistance is a 4 ohm. This resistance is a parallel combination of the two. How much is the parallel combination of the two? 9 is parallel with the 6. Find out the value. I am expecting the answers from your side. Yes. Avinash. Yes.
3.61, sir.
3.6. Now, how much is the RTH? This RTH is equal to 4 plus 2.61. That is 7.61 ohm is the RTH. This is right. If we know the RTH, if we know the VTH, then complicated network is replaced by the Thevenin's equivalent network. I will write the same thing and we will find out its answer. If we know VTH and RTH, then complicated network is replaced by Thevenin's equivalent network. Thevenin's equivalent network. How will be the Thevenin's equivalent network in this case? Thevenin's equivalent network will be something like this. There is a source with this resistance. This is point A, this is point B. How much is the resistance? 7.61. This is 7.61 is the RTH. How much is the VTH which we have calculated? Just I will check it out. This VTH is 3.24. This is 3.24 volt. This is plus and this is minus. How much is the load resistance? Now check it out. This galvanometer is the load resistance having the resistance of 10. Yes, I will reconnect the galvanometer here having is 10 ohm. And we will find out its load current. Whereas IL is equal to 3.24 divided by 7.61 plus 10. How much is the value? Final load current. Yes, anyone? How much is the final answer? Yes. Nagnath.
Sir, 0.18.
Sorry?
0.18.
0.18 amperes is the load current. In this case, if we are trying to find out its value of the load current, which is 0.18 amperes is the load current. I will check the answer with someone again. Yes. Anyone has the answer? Yes, Rishikesh.
Sir, correct है.
Correct. Ruchira.
Sir.
Correct. Shauram.
Correct, sir.
Correct.